Okay, the main functions are what is called the sine, cosine, and tangent. You will see this written mostly like this, S-I-N. You will see this written as C-O-S. And you see this written as T-A-N. Okay? You always take the sine of an angle. What goes here is an angle. You take the sine of a 30-degree angle is this. The cosine of a measure of an angle. Tangent of an what? Angle.
So they're all referring to angles?
When you take the sine of an angle. In these trig functions, there's going to be three numbers. One will be an angle, one will be the length of a side, the other will be a length of a side. Okay, you can use trig functions when you have right triangles to find lengths of sides or the amount of it or how big an angle is. The sine of an angle is always equal to the opposite leg over the hypotenuse. And when I say that, I mean the length of that side. Okay? And we'll explain more about that before we get this down. The cosine of an angle is always equal to what is called the adjacent leg over the hypotenuse. The tangent of an angle will always equal the opposite leg over the hypotenuse.
Is that the same as the sine?
I'm sorry. What did I say? Hypotenuse. Opposite leg over the adjacent leg. Sorry about that. Opposite leg over the adjacent leg. Now, you're going to hear an acronym said a lot because, or a jingle to help remember these. I've never been a big fan of that, but for this, it's not too bad. So, ka, toa. Why do you think it's said like that? So, S is for opposite over what? Hypotenuse. Ka, cosine is adjacent over what? Toa, tangent is what? Opposite over what? Adjacent. It's a good thing to remember. I'm going to erase which ones here are the hypotenuse. I'm going to call this A, this length of this side A, the length of this side B, the length of this side C. Okay? Now, pencils down. You can write this down in just a second. Everybody look up here. This is important here. I just want you to see this. It's always sine of an angle. And for instance, I'm looking at Caleb right now. And from my perspective, Laura's sitting to my what? It's Laura's to the what of him? She's to the left of him. But from Caleb's perspective, Laura's sitting to the what? So perspective is a big deal. And the point I'm getting at here is everything is from the perspective of the angle. Depending on how you look at it, the adjacent or the opposite changes. Does that make sense? However, what probably never changes? The hypotenuse. Just as she's still, what doesn't change between that? I could say she's sitting northwest of Caleb, because that way's north and that way's west, right? Whether he's sitting there, I'm sitting there, she's still what? Northwest. It doesn't matter. But from my perspective, she's to the left of him. From his perspective, she's to the right. Okay? But from both perspectives, she's sitting northwest of him. Okay? Same thing is said to be for the hypotenuse. No matter what in this triangle, what is this one going to be? The what? That's the hypotenuse, isn't it? Now, what deals with perspective? Well, when I find the sine of A, everything is from the perspective of the angle. So when I think of sine of angle A, it's going to be the opposite leg. Now, which leg is opposite angle A? Would it be B?
Yes.
So it'd be B over, what is the hypotenuse? So whatever the sine was, no matter what numbers I put in here, this was 5 and this was 10, it'd be what? 5 over what? 10. You see the point I'm making there? Now, again, right here, right here, right here, right here, here, and then the rest down there. Okay, cosine of A. What's the difference between cosine? Instead of being the opposite, it's the what?
Adjacent.
What is it? Now, there's two sides adjacent to angle A, isn't there? But one of them is the what?
Hypotenuse.
That's not the adjacent leg, is it? What is the adjacent leg here? Over the hypotenuse, which is still what? To find the tangent of A. What is the opposite leg? B over, what is the adjacent leg? Have a good day. That's not so hard, is it? Now, stop writing, pay attention. What do you say we find the sine of B? Or not B. Let's find the sine of C, the cosine of C, and the tangent of angle C, and see how things change. The sine of C. Well, how has my perspective changed? When I talk about opposite, instead of starting from A, I'm saying opposite to what? What is the opposite of C? Over the hypotenuse. That's still what? C. What about the cosine of C? What's the adjacent leg? B. Over, what is the hypotenuse? C. Tangent, opposite leg over what? Adjacent. So it'd be, what's the opposite one? Over. So you see how perspective-wise, They do change?
Is the adjacent always to the left?
No. It was to the right of this one from, what did we just talk about? Perspective.
Yeah.
So should you worry about right or left, probably?
No, I just.
Adjacent means beside, right?
So why couldn't it be C?
Because what is this called?
Well, that's not a button.
That's not a leg.
Well, how do you know that B is not the opposite leg? How come A is opposite then?
Because which one's opposite it? A. Which one's it not touching? Think about it. Angle C is always going to touch one leg and always going to be opposite a leg. It's going to be opposite the one it's not what? Touching. The one it's not touching is the opposite. The one right next to it is the adjacent.
So what about angle B?
Huh? Angle B is a 90-degree angle. We don't talk about that one. Don't make it harder than what it is. But when it comes to just simply following directions, and if you know this, is this that bad?
No.
No. Okay. Write that down. Will there be a lot more to this?
Yes.
Yes.
Of course.
Always is.
That's why it would help not to sleep. Shh. What we're going to do is we're going to talk about the three types of problems you have. And the number one thing you need to remember about these most of the time, the picture, I know. Is there people still writing? This isn't always the case. Most of the time, the picture will show you what trig function to use. Are we ready?
No.
Have you got it all written down?
Yes.
Well, then why aren't you ready?
Because it's going to get harder.
Stop whining. Okay, right now, just listen to me. And I tell you what, I'll make a deal with you. I'll go make copies of this if you'll just watch.
Heck yeah.
Okay? But I see people fall asleep. I'm going to freeze it and make you write it down. Deal? Okay. Most of the time, the picture will show you what trig function to use. We have three trig functions. What? Sine, cosine, and tangent, right? What do I mean by that? Well, you're always going to have an angle, right? With respect to that angle, they're going to give you some things, some information. What we're going to do is basically solve equations that have trig functions in them. Believe it or not, it's not as hard as you might think. Trust me, I would much rather solve this than a complicated quadratic formula. They're easy equations to solve. The problem is you see the sine, cosine, tangent, and you freak out because it's something you've never seen before. when it's all said and done, that sign of a number, it represents a decimal. Okay, it represents a number just like anything else. Just like the number 4 is just a number, cosine of 30 degrees is what? A number. Okay, so you treat it as such. Now, let me get going. Now, I want you to look up here at this one. What I mean by the picture will show you what trig function to use is this. They've given you 3 things, correct? Now, first of all, with respect to our angle, what did they give us? Where is our angle? It's right here, is it not? This is our angle. With respect to our angle, what did they give us? What is this side with respect to that angle? What is this side with respect to our angle? So they gave you a what? O and a what? All you got to do is look up here at this and say which one has O and H. So, how would I write my trig function here? Sine of an angle. What is our angle? 40 degrees is equal to the opposite. What is the opposite? Over the the hypotenuse, which is? Do you see how the problem told us which trig function to use by what they gave us? With respect to the angle, they gave us the opposite and they gave us the hypotenuse. So O and H, I use what? Sine. It's always sine of a what? That's important. That will alleviate a lot of confusion if you realize it's always sine of an angle, cosine of an angle. So x in this 10 should never be beside the sine, should it? Right? Okay. Like I said, this just represents a number. Okay? When you have a problem like this, where your x is right there, anytime your unknown is one of the sides, you are going to put that over 1 and you are going to cross multiply and solve. Shh. Don't jump. I'm going to multiply this, so I'm going to do sine of 40 times 10 is equal to 1 times x is just what? Okay? Now, what did I tell you? That this represents what? A number. And what confuses you? It's something you haven't done before. But guess why do you think we have these things right here? They're called what?
Calculators.
All I got to do, have I not already solved this basically? Would you agree? I just have to do the multiplication. All I have to do is come over here, press the sine button. Sine of what? 40. I'm going to close my parentheses. See that? Times, what am I going to multiply it times? And then I press.
I don't like that.
What do you not like about it? It's an ugly number. Let's round to the nearest hundredth. So x is equal to 6 point what? 43. You're already done with this problem. Now, how are you going to show your steps and work? By writing that, and that. Yes. You don't have to write cross, multiply, and solve. Once again, I told you guys I'd make copies of this if you would listen. Now, everybody try to do that on your calculator right now. Go. Make sure you get the same answer. Use your phone then. Sean, use your phone.
Hey, Coach, if we're gonna do this assignment, can we like?
Mine has a button. Sorry, I didn't mean to interrupt you.
No, can we set the fix to the 100 instead of already rounded for us? If you just want us to round it to the 100.
Don't make it harder than what it is. You can round, can't you? Just have it on regular degrees. Here's another thing. You guys see how that says DEG? You see it?
Yeah.
That means my calculator is set to degrees. There is another way of actually measuring angles, and it's called radians. If you see RAD or something else besides that, or you don't see a D, you need to change it and you bring it up to me and show me. Now I'm going to show you how to do it on a different calculator. This calculator is a scrolling calculator. It puts it out there as I put it down. Okay? This calculator is one of those ones that every time, like if you put 4 times 3, it blinks, doesn't it? See how there's not a scrolling thing on there? This kind, you do it in the opposite order. This kind, it shows you what you're doing, right? So this one, you're going to put the angle in first. So I'm going to put 30, or no, what was my angle?
40.
I'm going to put 40, then press sine, and then press times 10 equals.
Oh, that's confusing. So first angle and then the button and then
Right.
times whatever.
Basically, you've got to tell it what to take the sine of. If you just have 0 here and you press sine, you're taking the sine of 0.
Yeah. I need
Does
to
that
learn
make sense?
calculating.
No, it's fine.
Yeah.
This is actually the kind I used in college. But basically, here's the way you can tell what type of calculator you have. Go 4 times 3. Do you see 4 times 3 on your calculator? If you do, it's a what? It's a scrolling, it's like the first one, right? Look here. 4 times 3. See how this one says 40 and all I've got 3? Both of them you get the same answer, but one only, this one shows you what you just did, and it's, it's like 2 lines. Which type you have, that's how you know.
Thank you.
Uh-huh. All right, on to the next one. That is a 50. Quit trying to talk and just listen. Now, once again, what did I tell you guys? The picture will tell you which trig function to use. They've given us 3 things, haven't they? So, first what? Because there's my right angle. Okay? With respect to that angle, what's the 8? Now, so that they've given me an angle because there's 2, remember we said with respect to the angle, there's 2 legs with respect, there's always 2 legs, right? The one connected to it or beside the angle is adjacent. The one that's not connected to it or opposite is what? Opposite. So wise, it's really truly not. Okay, what's the right thing to put there? I always put what with the trig function? A, angle. What is my angle in this case? No, it's 50. That's a degree sign. And there's 2 is where what? Look at compare these 2. That's why I'm kind of doing one of each, the 3 types that you'll deal with here. Equations you'll solve. Look at this. What's the difference between this one? Here the x was at the top. Here the x is at the bottom. Now how does that change things? Watch. When we cross multiply, it just is. What is this? It's just a what? It's just a number. It's just an ugly number. Don't discriminate against us ugly things. It's not our fault. Be a nice person. So guess what? If I divided both sides by what's, I'm going to go 8 divided by what? Cosine of what? Isn't that it? 12.45? I should put approximately, shouldn't I? I should have put it on the other one too.
Wait, so the 2 little zero marks?
That means approximately. So when it's all said and done, was that hard? Do you see what I mean? A quadratic, in this case, is x, is equal to what is its opposite, 5 over adjacent, which is. Now, here's the thing. I can't divide both sides by tangent. Is there something I can help you guys with over there? Everybody look at the tangent button on your calculator. Kills me that this doesn't do a better job of that. I don't know if it's that or what. Okay, I turned the light off. It did much better. What's above that? The inverse tangent function. That is what you use. Okay, so when you don't know, when you want to say the tangent of what, question mark, is equal to this, you use inverse tangent. This is what I want always written on your paper every time. You're going to say tangent to the negative 1 power of parentheses. You move that inside it. 5 over 2 is equal to x. What happened? I changed that to what? Inverse. You know, if you go there and you change it over to radians, gradient, you want yours on degree. If it's not on degree, like, okay, I'll change it to radians. And watch. Inverse tangent, 5 divided by 2, 1.19. That's because it's in radians. Okay? However, I change it to what we wanted on degrees, and I go inverse tangent of 5 divided by 2, close my parentheses. I end up getting 68.198. Okay?
So is mine on the right one?
Yeah.
Thank you.
So you're basically going to have 3 types of problems to solve. A problem where what? This is your unknown, you cross multiply and solve. You're going to have a problem where what? That is your unknown, you're going to do what? Cross multiply and what? Or you're going to have a problem where you're what? Angle is your unknown, then you're going to find the what? Inverse trig function, aren't you? And I expect to see that written down.